All right, and we're back to it with another lesson. We're going to continue our conversation of working with points, lines, and planes. And what we're going to do today is specifically look at, all right, working with lines and planes in 3D. So we're going to look at some pictures that involve multiple planes, all right, some three-dimensional pictures, and see if we can kind of take what we learned in our last lesson and apply it to these types of situations. So the main focus here is on standard 2. Standard 2.1, I can identify and name planes. Standard 2.2, I can identify and find points that are coplanar and non-coplanar. Standard 2.3, I can determine if lines and planes are parallel, skew, or perpendicular in 3D space. And then 2.4, I can find and name intersections of lines and planes in 3D space. Now, we will also be going back, and you'll see some of the same language and notation and some of the words that we've talked about in our prior lessons. All right, so that's kind of embedded within this particular lesson. All right, so now, once again, for the opener. All right, wherever you're at, so find the room you're in or get to a room. And what I want you to do is, all right, go through these 5 questions and see if you can figure out, all right, what the answer would be, and maybe try to find an example of this in your room, all right, and write that down. So go ahead and pause the video, do the opener, flip it back on, and we'll see what you came up with. All right, so what is formed when 2 lines intersect? All right, so hopefully what you said was that maybe you get a point. All right, and what I think about, and when I look at the room here, I've got the ceiling tiles. You guys may not be able to see that. Let me see if I can kind of turn here. You guys can see the ceiling tiles, and you can see the little metal bars that hold the tiles in up there, and they cross, right? Ooh, sorry, about to fell off. The computer about fell off there. All right, so they cross, right? And where they cross at that point. All right, for me, so that's what I looked at. I'm like, oh, I have a very easy representation in my room that I could see that, right? Okay, now what is formed when 2 planes intersect? Now, when I look at this in my room, once again, all right, you guys can kind of see behind me, right? I can see the ceiling and the wall intersect, right? Okay, or maybe you can see my orange post here and my green wall intersect right there. So what you see is when they intersect, it doesn't just intersect in one point, right? There's a seam or there's a line or a line segment. So hopefully you said, okay, that you're going to get a line, maybe said, or a line segment, depending on whether it just stopped right there, right? Okay, now what happens when a line intersects a plane? All right, and so the easiest way I can do that is just take my hand and have my pen be the line, my hand be the plane, and then if it intersects right there, right, and maybe you guys can see the point there, maybe you can't see the point, it didn't really show up very well in my hand, I can make it a little bit bigger there, maybe I should have used a pen, right, but when it goes through, what we get is a point, right, so when a line intersects a plane, we get a point. All right, and the way I think about that is thinking about, all right, like if you had to put in a pipe, like maybe you had an air conditioning unit, or maybe you had a hot water pipe that had to go in, right? You'd have to drill a hole in the wall, right, to let that pipe go through, right? And so that's kind of a way of thinking about when a line intersects a plane, right? So we would get a point. Now, some of this, right, is not looking at special conditions. So some of you might have said, well, what if the line's in the plane, right? And then we would get all the points on the line when intersect a plane, right? So there's other kind of exceptions, right, that we could talk about too, but this is just in general when we're not talking about those kinds of things, right? So what is formed when 2 planes intersect? Well, we're assuming that they're not lying on top of each other, right? So like my notes here, right, they're lying on top of each other, right? So then technically they intersect everywhere, all right? So we're thinking more of, you know, when they're like this, right? Those kind of things, right? So, all right, so notice there are a couple of special exceptions, but we're talking about in general what happens. All right, so find an example of 2 lines in the same plane that do not intersect. All right, and for once again, when you look at my ceiling tiles up there, if you guys can see those, you can see that we have parallel lines, right? So we have lines that are like this. All right, so notice they're in the same direction and they could be put in the same plane. All right. Okay, and so I call these are called parallel lines, right? And you guys have probably seen that and heard heard that term before. Now, the new term is this: find 2 lines in different planes that do not intersect. All right, and the way I'm going to help visualize this is to take my 2 pens, and so notice right now they're going in the same direction, they don't intersect. But notice if I rotate one of those pens, I'll try to hold it maybe like this, right? So notice now they still don't intersect, but they're not going in the same direction. And so I couldn't put them in the same plane, right? So if I kind of rotate like this, right, you can kind of see that, right? So this is what we call skew lines, all right? So they don't intersect, but they're not going in the same direction like this, right? So notice if I took these 2 points, all right, I could take or 2 pens, I could take them and lay them all right, like that, right? And they're in the same plane, which would be that piece of paper. But if they were like this, right? So if I think about them turned like that, right, to where they're not intersecting, notice if I took those and put them in the plane, right, this pen is still above. I can't put them both in the same plane, so therefore they're non-coplanar, term from last lesson, right? So that would be an example of what we call skew lines. All right, so hopefully you kind of looked around, and part of this is to help you start seeing, right, how does geometry frame our world, right? How do we use these terms? Why does it matter, right? So we want to know that a wall is a plane, right? We know how to represent that, or the intersection is a line, right? Those kinds of things. Okay, so just to kind of summarize right here, if we go down to your notes, all right, when two lines intersect, right, they intersect in a point. All right. If two lines do not intersect or in the same plane, we say those are parallel lines. Now, I didn't mention this in the last video, but if I'm going too fast, this is the great thing about the video. Pause it, write what you need to write. You can turn it back on and listen. So I apologize if I go a little bit fast. All right. So you can always slow me down by hitting that pause button, right? Okay. So if two lines do not intersect and are in different planes, that's that last example I gave you with my markers. We call those skew lines, S-K-E-W. When a line intersects a plane, they intersect at a point. And once again, right, we're assuming that the line is not lying in the plane. Then they'd obviously intersect at more than just that one point. All right, for a line to line a plane, so this is what we're talking about, for a line to line a plane, so my pen in the plane right here, right, my marker, right, at least 2 points on that line must also line the plane, right? So if we get the 1 point, right, so the end of the pen right there, you can kind of see that coming up to you there, right? So if we only get 1 point, that's in the intersection piece like we're talking about right here, all right? Now, when two planes intersect, they intersect in a line. If two lines or planes are perpendicular, they intersect to form a right angle. Okay, and we have that symbol, right? So you normally see like this little box like that to show that it's right angles. And that's important, right? Most of the time when we build a building, right, when we're constructing a building, we're engineering that building, right? We want the floors, right, and the walls to be perpendicular. We want those to be right angles. Okay, now the walls aren't always right angles depending on the structure that you build. My room has a lot of walls that intersect, but not all of them are at 90-degree angles, and that's what creates different shapes on the interior, right? But when we're building vertically, right, we definitely don't want a wall to be leaning in or out, right? It will not hold the weight of the roof and the things above it, right? We want that perpendicular, all right, to make sure it's structurally sound. All right, so what we want to do now is flip the page, and what we're going to do is just go through, all right, this problem, all right, and answer some questions. All right, so when we look at figure 1 here, all right, we have basically a cube, right, a box here. Okay, and it says you may assume lines that look parallel or perpendicular are. All right, so we're not trying to fool you in that picture. All right, and we'll talk about some of the ways we add notation and language and things to our pictures to help us with that. Okay, so now when we look here, right, name two line segments parallel to HR. So here's HR right here. It says kind of back corner. So it has to be in the same plane, all right, and not intersect. So if I think about the side here, notice HR would also be parallel to segment EP right there. So there's EP. Now I could also take the back wall here because HR is also in this back wall, all right, which means it would be parallel to GS. So notice they're in the same plane, they're going in the same direction, they're not intersecting. All right, now there's actually one more that most people can't see. All right, I'll give you about 15 seconds if you want to pause the video, all right, and think about it. There's actually one more line segment or line that you might consider that would be parallel to HR. All right, now it's FQ right here. So notice FQ, I could draw a plane through those 4 points, kind of diagonally across the cube right there, right? And so the other part of this is, remember, not everything is illustrated, right? So we can kind of see the planes for the tops, the bottoms, and the sides by the drawing, but we can't put everything in a drawing, otherwise it would become overwhelming, all right? So the thing that you can think about, and as we go through this, I'll share some things with you to help you visualize that, right? But think about going in the same direction. So I think, oh, this looks like it's going vertically. So technically it could be parallel to anything else that's vertically, which would be like these three things. So think about like poles, right, or flag poles, things like that, right, that might be vertical, right, structures, and they would be, all right, parallel. All right, now let's move on to skew. All right, so we want to name two line segments that are skewed to HR. So it can intersect HR, all right, and not in the same plane. So to me, this is just like what I was saying earlier when I'm holding up my pens, right? So they're kind of in different directions. So what I see right away is if I have HR, which is that back corner, I have EF up here, all right? 'Cause they definitely don't intersect. They're not in the same plane. To me, this is going like left to right, while this is going up to down, all right? So different directions, do not intersect, different planes. So that would be AF, all right? Another one would be QS over here, right? So QS definitely doesn't intersect HR. They're not in the same plane. They're not going in the same direction. And so there you go. And there's a few other ones in here. All right, maybe you have some of those, all right, that you want to write down. Okay, now which plane is parallel to EFH? Now remember, we only picked 3 letters to name our planes, right? So EHF is this top plane. So the plane that would be parallel to the top plane would be the bottom plane. And remember, I only had to pick 3 letters in this. So I'm going to pick P, R, and S. And as long as you pick 3 letters in this plane, you're going to have the right answer. Okay, which plane is parallel to EHP? Well, EHP is kind of this left side over here. So then parallel to EHP would be the opposite side, all right, which would be this side over here. Now, once again, any 3 letters of F, G, S, and Q in combination, right, would give us that plane. Now we want to name a plane that is perpendicular to plane FQS. So FQS is this side over here. Now, there's lots of answers here, right? So if this is a true cube, all right, then all the sides that connect, right, should be perpendicular. So I'm just going to take, all right, this front side here, EFQ, but you could have taken the back side, FGS, right, or the base here, or the bottom. So lots of things should be perpendicular if we have a true cube there. All right, name a plane that is perpendicular to HRG. Well, HRG is the back here, right? All right, so once again, everything should be perpendicular to that except for itself. So I'm going to take the bottom this time. I'm going to go with PRS. Name all the planes that contain points H and F. Well, if I look, F and H are here. They're definitely in this top plane up here, right? So EHF. Now remember, once again, you see 3 letters in this plane, right? Now there's one more plane. This one is, once again, the one that sometimes is difficult to see because it's not necessarily illustrated in our figure. And that would be FHQ. All right, FHQ. Now, here's how you can know if you can name a plane. If you can draw a triangle, that means you can form a plane. All right, and that gives you a way to know that if 3 points are non-collinear, right? So I can go FHQ, that's definitely a plane, right? FHR would give me the same plane, right, if I continue and extend that. So that's a good way of thinking of, is this a good plane, right? So if I can draw that triangle, then I know I can create the plane. All right, so name 3 planes that contain G and S. All right, so G and S is this back corner back here. So that means we have the side over here, so FGS. We have the back wall also contains that, so I'm going to go HGS. All right, and then, all right, we got the back wall, right? Side wall, right? And then once again, all right, what contains GS is that diagonal plane, right? If I go across right here, right? So EGS. There you go. All right, so now I'm going to slide my picture up a little bit just so we can see the question. All right, name the intersection of line EF. So here is EF, that top corner, right? Closest to us in the picture. And plane FGS. So that would be this side over here. All right, so what are those 2 things in common? Or let me pull it down here. So EF is right here, and then FGS is this side over here. So notice I trace everything. That's going to really help you see what they have in common. So there's EF, there's FGS, and the only thing that I trace when I do both of those is point F. All right, almost there. 3 more questions here. Name the intersection of RS. So here's RS right here, and plane HEP. So HEP is this plane right here. So once again, I'm going to trace that whole plane, HEP and RS. And once again, once I trace all those, it's a great way of helping you visualize what they share, because what they share is going to be the intersection. And in this case, that's point R. All right. Name the intersection of plane HRS. So HRS, right, is this back wall right there, HRS, and PQR. PQR. That would be this bottom right here. So when I trace the bottom and I trace the back, notice what do I trace in both of those? That's right, RS. All right, so really taking your pen or your pencil. It's hard to highlight everything when we're using the same figure for so many questions, but tracing it with your finger, with your pencil, right, that'll really help you see that. Last question, and we're done here. Name the intersection of plane EHR. So EHR is this left wall right here, and FQP. And then FQP is the front wall. So if I trace the front wall and I trace the back wall, all right, what do I trace in both cases? That would be segment EP. All right, my friends, so that wraps up our lesson on lines and planes, all right, in 3D space, and we'll continue with this conversation tomorrow. So if you have any questions, some things don't make sense, make sure you're highlighting those, putting a star by it, writing those questions down, bring those to class, and we'll get right to it. See you then.